So, where we are at questions, I remember the saying is 1 horse and 1,024 chickens. That was the accurate number. So, Don Stanzione commenting for you. Any questions about energy consumption? Jeffrey? Yes, Kate, please.
Tevfik, fabulous talk. Thank you so much. And you know what I'm going to ask? What would be your ideal testbed for this kind of research?
Yeah, that's a great question. So one issue with power management is during Jeff's talk, there was a question about it, correct? So there are not so many hardware counters available, and the available counters are not necessarily very fine-grained. But given that also at the software level, there are not many profilers which can provide fine-granular, like method level or beyond profiling information. There are tools which can provide like process level power management information, but fine-granular profiling and monitoring of how much energy is used for what. So that's, I think, one of the most important problems we are facing right now.
It's really more of a hardware necessarily availability type of thing. Yeah.
Yeah, thank you. Yes.
Larry.
Yeah, so in talking about how the different ways of doing some of this energy conference, you mentioned TCP, right? So one of the issues with TCP, right, are keep alives and things like that, where the thing doesn't quiet down. But it strikes me that that problem occurs at the lower levels of some networks, that link layers, just even between two endpoints are always chattering. And so it's really sounds like you need a fundamental revisitation of a bunch of these error handling and reliable transmission protocols. Is there more we can do there? And I also agree that today we don't even monitor it because it doesn't shut up. So it doesn't vary.
Yeah, that's a great point, correct? So, I mean, almost at every layer, the networking stack we are using today are many decades old, correct? So basically, TCP is not efficient in terms of performance, and it is very inefficient in terms of energy consumption, correct? I wish there was an easy solution for changing the entire networking stack, but that's not an easy problem. But there is also a lot which can be done at the application layer, since many application layer like data transfer tools, they don't really consider efficiency, correct? They just, some of them try to optimize the performance, but almost none of them tries to be efficient in terms of resource utilization.
Yeah, I mean, there's no question about that there's benefits to be had there. I guess what I'm trying to come to grips with is what are the relative benefits given the difficulties at those lower levels. I mean, I think the other thing that you might look at is when you look at the more modern network implementation, high bandwidth network implementations, I'll focus on Ethernet. You get into these multi-channel implementations in order to achieve the bandwidth. And there is some work going on where you try and turn off some of the channels, but how do you predict when the right time is? And then you have the startup time to turn the channels back on. And certainly there are some things you could do at the higher level to try and not so much predict it, but at least to anticipate it when you're about to go do some work, and maybe there's some fruit there to be harvested.
I mean, yes. So I mean, that's a great example. So there is a lot of work on sleeping components which are not used, but then when you want to use them, so you need to wait for them to wake up. So and that's a very big performance bottleneck. So I mean, there are some prediction mechanisms as a solution, but they don't really work perfectly, correct? So it is always a sacrifice from performance when you take one of those approaches. In this approach that I did present, we can both achieve high performance and high energy efficiency at the same time, which is one of the beauties.
Well, an AI pattern recognition you would think would be a benefit here. Mm-hmm. I can see that. Yeah.
Join me saying thank you to Tevfik for the presentation.
Thank you.